Alrighty, happy Thursday. We made it. It's a long day. It's okay. I have the Python elective course, so all the students in the computer science major have to take a language elective. They can take Python, they can take Java, they can take C#. And Python's pretty popular, so I've got 60 students at 9:30 in the morning because for some reason someone thought 9:30 was a good time for a class. They didn't ask my opinion, which is unfortunate, but that's okay. So this is fourth cup of coffee today, and these are like mugs, so they're already doubles here. So I'm still on the struggle bus, but we'll get there. We'll get through it. We're going to spend a little bit of time today on some Python review. Nothing super interesting here. I think, did I change it in this one here? We also have to talk about Unix. I forgot we had to do that here. So this one? Yep. So we got to add Unix because the lab we're going to do on Tuesday is the Unix lab. Oh, okay. Yeah, I added it to this one, but I didn't upload it. That's what happened. Let me go upload that one to Canvas. I just forgot. Put that one back out here and replace. Okay. So a little admission, I haven't done this since last semester. It'll probably still work, but I should have tested it, and I thought of that at like 150. And I was like, I didn't test to see if it worked this week. So we're going to find out, but it should work for Unix here. So there's a couple tools we're going to use to do it here. So in Macland, you have a shell built in. You can use SSH to remote connect to another computer. That's built in on Macs. On Windows, you have to use another program. Or lately now, the later versions of PowerShell have it. Depending on what version you're running, what version of Windows, and what console prompt you have, what terminal you have, it may or may not work for you. So there is a tool you can go get called Putty, which will let you go and do that for free. This is a free tool. You can go download Putty if you want to do SSH stuff. Connect to, and that's what the Unix server runs. So you can connect to it remotely using that. It's available on the U of M network. So if you're on the Wi-Fi here, it should work. If you're at home, you have to use the VPN. I think they let you guys use a VPN. I know faculty can do it. I don't actually remember if students can. But someone said yes. Okay, so that's good. So you can use Putty if you want, if you don't have SSH built in already here. So again, depending on your version and shell and things, so the latest and greatest, Windows 11, Windows Terminal with PowerShell 7 for sure has it. I forget at what point it was added. I apologize. We should ask ChatGPT when I got added. It might remember. Or make up an answer. Who knows? So to connect in, we're going to say SSH, and then you give it the bunch of different commands here. So our server, right, we need the, which one? It was actually going to suggest it for me a second ago, wasn't it? There we go. Oh, come on, come back. No? What's the tab isn't doing it for me? SSH, login, arrow to the right. That's right. So these search, I'm still getting used to these happening in PowerShell. It's relatively new. So our server is login.umd.umich.edu, and then you have to tell it your login name is me, or whatever your unique name is. We'll do this in lab on Tuesday. I want to show it to you so you've seen it once. On the lab computers, it should just work great. We've got access to Putty. We've got access to the other tools that we need to do it on your own. You might need to try a couple things. Should work out well for you. But we need to tell it, hey, login is me, and then it's going to ask for the password, assuming everything goes well here. So it's great. Okay, here's the big prompt. Don't do dumb things with college computers, or you lose access. And whatever other gobbledygook we've agreed to here. Nobody reads this stuff, right? I don't think it's ever happened. There was a prize at one point. Someone, I forget who it was, I think it was an insurance company, had a clause like 7 pages down. There's like, if you read this, please email us here and we'll give you a $100 gift card. And it took them like 7 months for someone to find the thing. They're like, I'm glad you read your insurance policies. Like, sure. So now you're going to type in your password. It doesn't look like anything's happening. This is the weirdest thing. So it doesn't even give you like blank spaces. It just looks like nothing. Then if it worked, it should give you the duo prompt and say, okay, what do you want to do here? I like the duo push. You can do the phone call or the SMS, whatever it happens to be here, and you should be able to get logged in here. This is good. I'm glad it's working. I was going to be kind of sad if it didn't work. Okay, now I'm logged in. So this is my user account here at login. The tilde character here, that's the shift accent next to 1, typically on your keyboards in the top left, this is your home drive. In Unix land and Mac Bash, a lot of these are going to be similar here. If you're used to Windows terminal or command prompt or whatever, or DOS, goodness, it's been a long time since I used DOS. I'm an old person here. There's a different set of commands. So on the lab sheet I'll have for you, it's got a little quick hint guide on how to do all these things here. But ls is like list, and it says, what's in this folder? What's in here? And I've got a bunch of garbage out here because I've been doing this for a while now. Got some stuff out here. Right? Hey, I've got a folder. The lab exercise has you make a folder. So to get into folders, we don't have things to click on. This has been around since before computers had Windows or Mac OS or whatever they wanted to call theirs. I forget. Here, things to click on. So all you had was a keyboard. You didn't even have a mouse back then because we're going way back now. But that's fine. We can just work on the keyboard. So I could say CD for change directory, and I can say CIS 2001. Now, if you're not a fan of typing like I am, you can type a couple letters and start tabbing, and it should, oh, it's not completing. 2000, close. I've got too many things that are named similar here. But now it's /CIS 2001. That's the folder I'm in now. So in ls, I can see what's in here. Oh, look, I've done some lab stuff, and I should have cleared this out beforehand, but that's okay. So you can see there's files in here, and then these things that are probably folders that show up in blue here, right? Green look like other sorts of files here, like that's an executable here. If you want to see the contents of something, for some reason the command is cat. I don't even know what it stands for here, but you can say, I want a cat hello.py, and it gives you the contents of that file. My file says print hello world. That's all it does here. So if I want, I can tell the Unix server to run Python and run the hello.py script. Right? Remember when we use PyCharm, you get that little prompt at the bottom that says, hey, here's Python, here's the name of your script, and then you get all the output? That's what's happening. So we're doing it by hand, the terrible way, here saying, hey, please run Python, interpret this Python file. So if there's some sort of work we want to offload onto another server, because my laptop doesn't have enough power to crunch numbers or whatever, we could transfer the stuff over, SSH in, and then, hey, powerful server, you go crunch this stuff. And it can sit and spin on it for hours or whatever it has to do, right, to analyze a bunch of things. That's not tying up my laptop resources. So pushing things out to other servers is super popular. Doing it by hand is a little tedious sometimes, and we've got some more interesting tools. You know, Amazon sells all sorts of things in AWS. Microsoft sells all sorts of Azure services for these sorts of things that are a little more friendly to use, but they all sort of evolved from this. Right? Here's some sort of remote connection we can do to hop in, power some stuff, crunch some numbers, this sort of thing. So if we wanted to edit a file, this is where it gets ridiculous here, using VI or Vim here. We'd say, is it VI, we'll call it, I already have a test py. How about testing.py? We'll say, I want to open the VI program, and I want to make the file called testing.py. Now I have the wonderful VI editor available here. VI is old, been around for a really long time. If you know how to use it, you can be really good and really fast. There's a guy who streams on Twitch. This is the Primogen, or I forget how to pronounce his name, Primogen guy. He has done this for years and years and years and never takes his hands off the keyboards and can code 10 times faster than I can. Good for him. I just don't care that much. I like my mouse. You know, that's okay. In VI, you have two modes. There's edit mode, right, where we're actually editing the document, and then there's command mode. There's no mouse to click on things. There's no file menu. There's nothing to say, hey, I want to save this file. So you had to have two different modes. One that was editing your file and one that was giving it commands. So to get into edit mode, you have to type I. So I puts you from command mode. I is the command to get into edit mode or insert mode. Now we can start typing things like print, please work, quote. Here's my lovely Python editor here. Print line 2. Print, I'll do one more here. Print, please no typos. Great. Now, to save it, you have to get out of insert mode, back to command mode, and then quit. And this is where the big joke comes from that it's impossible to exit VI because nobody knows what the command is. And unless you've used it a bunch of times, you don't remember what it is. This should not be in my head what it is. You hit escape. So right now you see insert down here at the bottom. You hit escape to go back to command mode, and then you want :Q to quit. Again, I didn't come up with it here. I apologize. I'll have it all written out in the cheat sheet, how you do these things here. But :Q to quit, and it says, uh-oh, no write since last change. Add exclamation mark to override. I never saved my file. I didn't write the file. So it's saying, if you quit now, you're going to lose your changes. That's probably not what you wanted, dummy. So I could do :Q exclamation and lose my changes, or I could go save it first. So I think it's W for write. Yep, :W for write. It's not S for save. We're writing. Again, really old-fashioned. You write something to disk here rather than save to disk. Now I can :Q, and it says, okay, great, we quit. Then I can say, hey, let's do Python testing.py, and I get, oh, look at that, it actually ran. I did not have any typos. Again, it wasn't a very interesting Python thing here. But now we've gone and created a Python file by hand using the VI editor on a Unix server somewhere here in the college. I don't actually know where it is. It doesn't really matter, right? The cloud is just someone else's computer, right? That's our college cloud here, someone else's computer. So that's the basic get it started. Then there's some other commands we're going to do. So we're going to make directories. So to make a directory, make a new folder, there's no right-click new folder option here. You say mkdir for make directory. Sorry, it's a little different in Unix. Mkdir make directory, and we'll say this is, how about demo? And if I ls and list, I see now there's a demo folder. So if I want to move something from one place to another, it's a little weird. Generally, we like to copy things and then go delete things, just in case you screw up your move command. I think copy is a little easier, and that's what we'll do in the exercise. So we're going to copy, and we're going to copy the CP for copy. We're going to copy our testing.py. That's the source, and then the destination is where do we want to put it? Well, I want to put it in demo/testing.py. So move it from where it is, or copy it from here into the demo testing.py location here. And then if I change directory into demo and I list here, now I have a testing.py file. If I want to go back a level or up a directory, it's cd ... I don't know why. These sort of things don't need to be in your head. We'll have it as a cheat sheet here. They're in my head. I'm sorry. I don't know why. Else again. So now that I know it copied, now I can delete it here. rm for remove testing.py. And if I list again, now it's gone. Right? So I can see now the file's gone here. So there's rm all files and folders cursively. What is it here? Yeah. So the rm-rf is the bad command. Don't run this thing. It's remove recursive force. So from wherever you are, it will just wipe everything out. So some people think it's funny to make people do bad things here, because haha, we tricked you because you didn't know any better. Like, oh yeah, change directory to your root here, and then rm-rf. Just wipe everything on your drive. And you're like, oh sure, that'll fix my problem, right? And they're like, yeah, it'll fix it. And then you lost everything, because there's no undo button. So just be careful with your commands when you run them here. I don't know why that was a thing people would make you do, but sure. All right, so we moved it. If you want to rename something, we can copy it to the new name and then remove it. I think there are specific Unix move command. I think there is one here. Honestly, I just have to go Google it here. Oh yeah, so you can do mv for move. We'll move it directly. Copy, I find to be a little bit safer in case you screw things up. Again, every so often you'll get in the terminal and do sorts of things here, depending on what you're doing. I spend a lot of time in PowerShell doing Windows Server things, not so much with Linux and Unix here. But you get used to this sort of thing here. And then it makes people think you're really smart and you must be a hacker, of course, when you start typing in a terminal like this with cool colors in it, right? And you just start jamming away. Of course, that's the fun stuff. So we'll do this exercise in lab on the lab computers, and then we can check our box saying, hey, we've taught you at least know that Unix is a thing, and you were able to successfully open VI, write a file in VI, and quit. And I promise you doing this in Python is way easier than making a C++ program that you have to have all sorts of curly braces and semicolons and things in the right spot for that. So at least ours is like 3 lines. It's not anything super complicated. It's a little bit harder for them, but that's the idea. So we can get in, we can get out, we can do all those things here, and then I think it's exit. Yep, we'll end your session. That's the technically right way to do it. You could just close the window, but exiting will shut down the session and tell the server to close it, other than it just timing out on you. Eventually you get timed out with your SSH stuff, and it just kicks you anyway, but this is a little bit cleaner, nicer way to do it here. So that's some of the stuff we're going to do with Unix. Looking forward to all of that fun stuff.
So for the U-Events server, we can run things on the server under our name as long as it's nothing like bad.
Yeah, don't do anything stupid. Yeah, so you've got access to it, you can run stuff. I think they've limited all of our profiles. Like, I don't think you have access to everything the server can do. I think you get like a small slice of it. There's like an access request you can get to get more power. It's a whole thing. I've never bothered with anything super big and fancy because it seemed like a headache to go and ask. And that's all. All right. Again, we'll do that Tuesday. I'm going to walk you through it for the lab exercise. That'll be a lot of fun. But that's about all we'll need to do then for lab on Tuesday, right? Because Python basics, almost all of you had the previous class before. Not too bad. If you're new to Python, it's okay. We'll get you caught up here. And then next week, we'll jump into object-oriented programming and start talking about our first project. We're going to kind of get deeper into this sort of thing as we go. Actually, we might wait for recursion, actually. Our first project might be recursion. I think we'll start a little bit slower because we need to get through more of the inheritance. Oh, I have to look again. I'm sorry. I'm really tired right now and don't remember. We'll get through it. And spill coffee on myself. That's fantastic. It's that kind of day. All right, let me fire PyCharm back up here. So I think I got all of your invites for the repositories. I haven't looked at all the lab submissions yet. We've got through next week if you need any more time to get those labs in as we go. So I'm going to go start a new project. And I'll make sure it's on our repository folder here. I'm going to be super confused because I have two different Python classes, but that's okay. We'll make it work. So 2001, and then apparently the latest version of PyCharm doesn't have a project name. I don't know why they'd take that out, but they did. So if you don't have the project name, just go add a slash something here, like test or project 0, whatever you want here. We'll get it set up there for you. The name box just essentially does that for you automatically. It's really confused they would take that out, but sure. So we'll call this one Python intro, and I'll do it in the same window. Come on. All right, how about we do something mildly interesting for a little recap refresher here. We're going to make a Powerball ticket class that will store the numbers from my Powerball ticket that you can buy, and we'll make a way for it to compare itself to another Powerball ticket to see if it won, right? Because they draw a bunch of numbers and say these are the winning numbers. So when we think about designing things in an object-oriented process, right, we want our class to have all the details and encapsulate all those details of what this object is, what the noun is. I'll have its attributes, the numbers that it is, and then the verbs, the thing that it does, is tell you how much money it won. Most of the time, your ticket will be worth $0 because that's how the lottery makes their money, and we tax poor people with the lottery. Right? Nobody wins money with the lottery. Some people eventually win, but it's a losing game. The state wouldn't offer the lottery if it lost them money. Right? We all understand that. So please don't waste your money buying tickets. I worked with a lady whose retirement plan was lottery tickets. I swear. She bought 2 a day, every day. She's like, when I hit the jackpot, I'm going to retire. Like, lady, it's like 2 tickets a day for every day. It's like $1,200 a year in lottery tickets. She's like, really? Do we not teach math anymore? I don't know, but just don't do that. So let's write a class for Powerball ticket. Powerball ticket, right? We'll have an init method here, and to create a Powerball ticket, we could either pass it the numbers here. Say, I would like this number, this number, this number, this number, or it could generate it randomly. So how about we have an option for numbers, and we'll say it equals none by default. So if you don't give me numbers, it'll be none, null, and I'll go generate them for you. If you do give me numbers, I'll go check them. Like, make sure you gave me good numbers. Powerball is a little bit particular in that it is based by combination, not permutation, so you can't have repeating numbers. And then they have to all be within the range of the correct numbers here. So just a couple things to check with that here. So, and again, we can come back to that later here. So we might say, hey, my self numbers, self.numbers is the numbers here, the numbers list. Now, if I give you a list and you store that list, I now have access to change your private variable here because you don't have a copy of the list, you have the same reference to the list, right? So I really want a copy. So what I want to do is get a copy of numbers here. So I'm going to slice the whole thing from start to finish to get a copy of the numbers so that you can't go change it on me later. You're like, oh yeah, I told you I wanted to buy 1, 2, 3, 4, 5, but I heard the winning numbers. I actually bought 2, 3, 7, 10, 12. And that just so happens to match the winning numbers. I've obviously got a jackpot. Right? Like, we don't want those numbers to change in us. So part of protecting the integrity of our class here is making sure you can't change the things. You don't have access to them here. So once you give me the numbers, I'll copy them and store them in here. Right? That's, I guess, really if numbers here. So if numbers, and again, we're going to be lazy here and not say if numbers is not none. Right? If it's none, it's false. Nones are always false. Python is truthy. That's our shortcut here. We're going to be lazy and say, if you gave me numbers, I'll go make a copy. Otherwise, now we need to go generate a bunch of random ones here. So we can go do that. We can say import random. And we want self.numbers then to equal a random dot sample of range 1 to 69, so really 70, right? Because we need to get up to the number 69. 70 is not included when we range, and we want to sample 5 of them, right? You want to take 5 random values out of here. And you can do it lots of different ways. This just happens to be the fastest one, I think, here using that. And then we'll take self.numbers. I think, does sample give me back a list? I think it gives me back a list, right? Returns a list. So in this little helper text here, it says it's going to give me back a list of something. So I have the list object. After that, then I'll take self.numbers, and I'm going to append another random.randint. Now, randint is inclusive of your endpoint. Thanks, folks at Python. That's confusing, but sure. 1 to 26 for the Powerball. Right? You get 5 numbers, 1 to 69, and then you get a 6th number, 1 to 26 for your Powerball number. Don't ask me why it's in my head. I like doing this exercise because I like to have people be able to pretend to play the lottery and see how fast they can lose money. Like, oh, hey, I'm going to win $100 million if I get a winning ticket. Okay, sure. Go buy 100 million tickets. You just lost $200 million. Or, maybe you won $50 here and there. The odds of winning are 1 in 2 billion, something. Oh, I'll just buy 2 billion tickets when you can win $2 billion. Well, you still have to pay taxes on the money that you win. So you lost 40% of that. And most of the time they pay you in an annuity form, which means you get a set amount of money every year for the next 40 years. And because of inflation, the value of that goes down every year after year after year. So if you take the money up front, you only get like 60% of it, and then you lose 40% of that to taxes. And I'll shut up now, I'm sorry. Lottery is a big scam. So we got our init methods. You can either give me numbers, and we'll just leave a little to do. Make sure these are good. Right? If you give me numbers like 1, 1, 1, 1, 1, 1, that's not good. But for now, we'll come back to that. Right? We'll do that after here. So I've got the Powerball ticket. Oh, it's telling me I don't need those parentheses. Sorry, I forgot. We're not inheriting from anything. Then maybe I might have a string representation. How do I represent myself as a ticket? Right? The string override. So if I wanted to print myself or do something with an instance of Powerball ticket as a string, this is a super handy override to have here. Right, this little override icon, we're overriding this so I don't get that garbage that says, hey, you're a Powerball ticket class at some memory location. That's not helpful for anybody. Nobody cares. Right, so I'm going to return. Now, again, you can do this in lots of lines. You can do it in one line here. The one-liner is kind of cute here. We're going to say I want to take a space and I want to join my self.numbers together here. Right, I want to space separate all my numbers. Right, take this list, put it together with a space in between everything. Right. That's just a quick shortcut. Right. And then lastly, maybe I'll have a get numbers function here that just returns. Again, I don't want to return the actual list because I don't want them to change it. I'm going to return a copy of the list. So I'll return self.numbers here sliced, right, to get a copy of it here. So I can go make Powerball tickets, and I can get them returned as strings, or I could actually get the list of numbers back out here to see what happens. So let's go try it. So let's make some Powerball tickets, right? So we'll say, ticket equals a Powerball ticket. I'm not going to give it any numbers, and then we'll print the ticket, make sure we get some random numbers, and we'll say another ticket equals a Powerball ticket, and this time we'll give it a list of numbers. Let's give it 1, 2, 3, 4, 5, 6 here. And we got a list of numbers, and we'll print that ticket here, and we should hopefully get 2 tickets back out, one random, one not. Oops. Oh, that's right. So I didn't give it a string. It's a bunch of ints right now, right? So we need to just change this up a little bit here. So I can't just say in self numbers because it's a list of ints, it's not a list of strings. So I have to say for string of number in self numbers. Oh no, shoot, I want string of number for number in numbers. I hate the syntax here. Right? It's the list comprehension. We're saying essentially we take a for loop and we put something else outside of it instead of inside the for loop to save us 2 lines of code. The book does this constantly. So hopefully we get used to using this sort of one-liner format. I usually like using the loops, but then it's, I don't know, it looks a little bit different here. So we'll get a string of the number for every number in self numbers here. Then we'll join them together with a space here. All right. I printed ticket twice. I was supposed to print another ticket. There we go. Wonder why they were the same. There we go. Now I have 2 tickets. 53, 5, 34, 49, 22, and 7, and 1, 2, 3, 4, 5, 6. Super fun, right? So now if I wanted to buy a bunch of tickets now, right? So I could say maybe for ticket in range 100, let's print Powerball ticket. I don't even need to save them anywhere. I can just make one and print it, make one and print it, make one and print it, right? We get a bunch of them here, right? They all look relatively random here. We could sort them if we wanted to. I think they're usually in sorted order. It doesn't actually matter. Right? They do that because it's easy for dumb people to compare their numbers if they're already in ascending order. How many matches did I have? People get confused really easily if they're not sorted, that sort of thing. All right, so we've got some Powerball tickets. Now we need to see how much money we won. Right? So I need to take a ticket, compare it to another ticket. Right? So here's the winning ticket. Here's my ticket. Tell me how much money I won. This is something we should be able to do here. So we'll get a define get winnings here. Winnings that accept as an argument the winning ticket. Winning ticket. Right? So how many matched? Right, is what we have to do. So if we go look up Powerball, how to play, goodness, yeah, we want your cookies, sure. Let's see. Prizes and odds, here we go. Again, don't worry about the power play stuff, that's just to take more of your money from you here. If you match the red ball, or 1 white and a red ball, you get $4, and it costs $2 for the ticket, right? So you get double your money back, essentially. 2 white and a red is 7, or 3 yellow, or 3 white is 7. So 2 different ways to win that prize here. 2 different ways to win 100, 1 way to win 50,000, 1 way to win $1 million, and then the grand prize, if you match all 5 plus that. And then, of course, the odds here, I'm sorry, 292 million, not 2 billion. I was off by 10, I'm sorry. So you might think if it's worth 200 million to win, you could just buy all 200 million tickets. No, but you're paying $2 a ticket and taxes and all this nonsense. And then if someone else gets lucky and also wins, you get half of it. So you're screwed right away, right? Because you just tossed a bunch of money in there. This is why rich people don't play the lottery. Right? Ask any rich person you know. None of them play. It's stupid. You got that already, right? I don't need to keep telling you that. I apologize. It just irritates me here. I've seen too many people who can't afford to play waste their money playing. And the people who can afford to play know better. Like, come on. Odds of winning a prize are 1 in 24.87. Woo, to win any prize at all. How fun is that? Based on $2 to play. Rounded to 2 decimal places. Nice to tell us they rounded. So it means it's probably even less than that. Right? If they have to tell us it's rounded. Sure. So forget winning. So if you get the grand prize, we get the grand prize. Well, we can say it's $1 billion. I don't really care. It doesn't matter what the number is. It won't happen here. So we need to check my numbers with the winning tickets numbers here. And now I think there's a way to check, was it Python list count matches into lists, something like that. Look at that. It's generating code for me. Thanks, Bing AI. It just takes a minute. here. I miss the old internet. It even has time complexity and space complexity analysis on this here. Like, it knows programmers use this stuff, or students, programmer students use this stuff too. Choose a language. I asked it for Python. Maybe it will generate code eventually. The sad thing is, like, it costs a lot of money computationally to run this chat AI stuff, and their companies are losing ridiculous amounts of money offering this because it's expensive. At some point, someone will sell it and make some money, right? OpenAI is still losing buckets of money, right? Pretty sure they are. Which is AI losing? That's probably not the newest article here, right? What's something recent? No, 2 days ago. At $200 a month subscriptions, they're still losing money. People paying them $200 a month, and they're still losing money off them. Whew. Oh yeah, this was September. $5 billion losses. They made $3.7 billion. That's kind of impressive. A decent amount of revenue there. But lost $5 billion. That's in addition to the money they made. Right? That's their cost of being $8.7 billion to run OpenAI for a year. They don't employ that many people, right? Like, their payroll's not that large of a piece of that here. Let's see if we got a result. Oh, something went wrong. Should we try again? It's going to fail again, isn't it? Should I just scroll down? I wanted to show you, like, a chatbot doing this for us here. All right. No luck. We can AND them together here. Oh, that's fun. Do a logical AND here and print the length of it. Turn them into a set. Sure. Get a set of it. Count to them. Results. A couple different options. More results. Those ones look fun. Print the length of W for W in list 2 if W in... Come up with a better variable name than W, please. Like W in W if W in W in W. Like, I'm super confused here. I like the set idea, but that seems like a lot of work here. Does this give us anything? Nothing yet. That's okay. I thought there was like a union command. Wasn't there a union command? What's like self dot numbers dot union? No? Really? Python list union? No, that's, oh geez. All right, I thought I was a built-in one, but I guess not. That's fine. We can count it ourselves. It's really not hard, sorry. We can say for number in self.numbers. Numbers. And really, we only want the first 5 to start with, right? Because we have to compare the white numbers to the white numbers, and then the Powerball number to the Powerball number. So we got to look at the first 5 first, and then we look at the 6th number to see how that matches, because that represents the Powerball number. We could have them separate and have white numbers and red number, if we cared to, or we could put them all in one list. That's just an option, right? We could store them either way internally. Probably doesn't matter too much one way or the other here. In self numbers. And we really want, again, those first 5. So we're going to slice up to 5 here to get the first 5 numbers. And then we can say if number is in the winning ticket dot numbers sliced to 5, right? Then we have a match. Now it's warning us here we're accessing a protected member. This is a little bit ugly. We're getting something that is supposed to be private here. So we could say get numbers here. Now the problem with that is we're getting a copy and then making another copy. So this is going to be rather inefficient. And at some point we'll look at efficiency, right, in this class. That was one of the goals of this class, is to look at efficiencies. But for now, sure, we can make a copy of a copy of a copy of a copy and have this in memory 7 times. Nobody cares. It's just one Powerball ticket. It's 5 integers, right? 5 integers store really, really easily on computers here. No biggie here. So what I really want then is the white matches. Starts at 0 until I know otherwise, right? And for every match here, we'll take white matches plus 1. If that number's in it, we're going to add 1 match, right? And then we'll have... we'll say red matches. Now, this doesn't even need to be a count here. We can just say, hey, my winning ticket dot, or my number, self.numbers numbers index of 5 is equal to the winning ticket dot get numbers index of 5. Does your 6th number match my 6th number? This is just a true or false here, right? I don't need to say it's a 1 or a 0, which is kind of already a true or false, right? So I can have that with red matches, right? So I have white matches and red matches. Now I just have to go through the prizes, right? So if red matches and white matches is 5, we're going to return, I don't know, what do you want to do, like $1 billion? And again, you can use the underscore as a digit separator because Python's fantastic like that. Just don't be dumb and add it more than places than you should because Python literally ignores it. It doesn't have to go places, right? So we'll return $1 billion. You want $1 billion, go for it. I'll let the IRS take their 40%. And then we're actually going to give you less than that anyway, so nobody cares. Right? If it's not that, now we could have an else if, but it's redundant because if you return, your function's over, right? Game over, it stops. We don't need else if, we just need another if now. So if this was not true, then we can check, hey, is white matches equal to 5? Return, hey, you win just a measly $1 million. No biggie here, just chump change compared to that $1 billion there. Which really, when you think about the difference between $1 million and $1 billion, it's hard for us to conceptualize here. And this is one of those things, let me put on my tinfoil hat and sound crazy for a minute here, but like billionaires have $1,000 million. That's a lot of millions of dollars there, right? And everyone likes to say the example of seconds here. How long is 1 million seconds? 1 million seconds, there we go. 1 million seconds is 11 days, right? How long is 1 billion seconds? 11,000 days. Or like the scale, the jump from million to billion is crazy high. Okay, sorry. Let me take off my crazy hat again here. So if we didn't match 5 and the red, we didn't match 5, then we can say, hey, if my white matches is 4 and the red matches here, right, that was going to be 50,000, right? If that wasn't true, then if my white matches was 4, then we return, now we got to go back and look here, 100, right? 4 whites or 3 whites and a red here. So we can say or white matches is 3 and red matches. Now, you want to be careful with your order of operations here, and I can really never remember which one goes where here, so I'm just going to force it. I think ors happen first and then ands. We spent a bunch of time, way too much time looking at this last semester, and I already forgot it here because that's not the kind of thing you need to memorize. So we'll return $100, right? So either one of those cases, we get $100 then. And if white matches is 3, or white matches is 2, and the red matches, then we're going to return, was that $7? Right? And then the last case, it doesn't actually matter if you match the 1 or not here. If the red ball matches, you get $4. Right? We don't even care about that first one. Like, why even bother putting it here? Because it looks like like there's more chances to win money here. This doesn't change your odds at all. It's like, so technically it's harder, but it's still, I don't know. Okay. So matching just the red and not the whites is less likely than just matching the red, right? Think back to ask any of your stats profs. They'll love to go off on lottery games as well. All right, so then if my red matches, we'll return 4. Otherwise, now we're just going to return 0. I don't even need an else case, right? It's just at the very end here, I'll return 0, right? Awesome. So now we can make this a little bit more fun here. Instead of doing 100 tickets, we don't even need to make those tickets here. We'll have a little prompt. We'll say, how many tickets do you want to buy? Right, so tickets will be an int of an input. How many tickets do you want to buy? And then I'll have a total spent is my tickets times 2, and a total 1 starts at 0, and then for ticket in range of tickets, right? We'll take my total 1 and we'll add the winnings to it here, right? So we need a winning ticket, right? So we'll have a winning ticket equals a new Powerball ticket, right? We'll generate the winning one, and then we'll go make a bunch of tickets. So ticket is a Powerball ticket. I can then print, I can't say ticket, shoot. I don't know. My ticket is a Powerball ticket, and then we'll print my ticket for fun so we can watch what happens here, and then we'll add the winnings. We'll say total 1 plus equals my ticket dot get winnings given the winning ticket, right? Take my ticket, compare it to the winning ticket. How much did I win here? Eventually, then we can print out your total total 1, and then we can do this as a formatted string, right? So we can do our interpolation right in here, total 1, or no, total 1, right? And with a pretty $sign. Oops. And then we can print your total loss, or total spent. There's a $sign with my total spent. And then we'll print your net loss, right? If it shows you're winning money, you've done it wrong. Right? You don't win money in the lottery. So the more you spend, the more you lose here. We'll take the total 1 minus the total spent. So that should be a negative number, right, for our loss here. Right? Whatever you won minus how much you spent here. So let's say, hey, I want to buy 1,000 tickets here. And look at that, we won $198. Not too shabby. Oh wait, crap, we're out 1,800. Oops. Don't buy 2,000 lottery tickets. Let's try it again. Let's do 100,000. We should format this, right? So we should do this as a formatted, what is it, comma separated 0 to D or something like that. No, we don't need to round it all. No, yeah, D, comma D? Is it just D? Comma colon D? Colon, comma D? I forget here how this works. Goodness. It's one of these here. Let's see if that one even works. 10. Nope. Oh, goodness. It's a format. Oh, I have too many colons in here. Colon, comma D. 10. Oh, it didn't crash on me. Let's do 1,000. Okay, good. So just colon, comma D. Sure. All right, and let's do, that's 100, 1,000, 10,000, 100,000, 1,000,000 tickets. So the printing is actually the slow part here, right? If we didn't have it print, it'd go a whole lot faster for us. There we go. All right, we won $229,000. Not too shabby. Oh, we're only 1.7 million in the hole. Oops. Right. I guess we didn't get the jackpot. Right? Should we do 292 million to see? So I'm going to just comment out the print for a second here. And we're going to run it for, what do you say? Our odds of winning were 292,201,338. So 292, 201, 338. 292, 201, 338. That was probably pretty close. We'll see. And again, because it's random, we aren't even guaranteed to get all of the unique possibilities here. We could get a duplicate of one of our own instead of a duplicate of the winning ticket. Right? Go back to your stats class. Just got to think about it for a minute here. You know, I promise it's faster than spitting out the output, but it still has to go through and do a bunch of things, and we're being a little silly copying our numbers around here. Let's see how much money we lost. The good news is you can't have lost more than like 580 million. Right? You can't be that bad.
I wonder how many times you'd have to run that before you actually hit a winning ticket.
The more often we do it, the closer we'll get to 292 million. But like every time we run it, we should be a decent distribution around it because it's relatively random. You know, it's not great. I'm in a bunch of online Facebook groups because I'm an old person and Facebook's for boomers now. But I promise I'm a millennial. But one of them is a D&D Dungeon Master group. And someone said, I just got a new set of dice, but I didn't think they were fair dice because they were like really pretty fancy metal dice. They're like, so, of course, I did what any normal person did and rolled them 1,000 times and recorded my results. Here's my chart of results. Do you think it's a fair die? And you should have seen the comment thread. Like, there's a bunch of people who have real strong opinions here, but several very rational people are like, oh yeah, we did the chi-square test, and no, it's not a fair die. Other people are like, oh, you should roll it a bunch more and see. And other people are like, oh, it's fine. It's never going to be a perfect distribution, which is correct. What you need to do is go do that 10 more times and see, make sure that the distribution variance, it's like all these things. Like, yeah, why are we spending this much time doing it? I don't know. Oh, goodness. Is it still running? It's still going. All right, we got too slow. With all these copies here, we made it too slow getting out the numbers here. I feel bad now. It'd be a little faster without that. But come on. All right, I'm going to give up on it for a second here. How far did we get? Set in the range. Oh, yeah, that's fine. So we'll just say in here, we'll add a little print for jackpot. just to see if it's running here. And maybe in here too, we can do this for fun. We can say if ticket modulus 10,000, we want every 10,000, every 100,000, right? How about that? Equals 0. We'll print just the number of tickets we've gone through, right? Just so we can see a little bit of progress here. Let's do 292,380,000, something like that. I don't know. I forget what the exact number was already. There we got 1 million already. 2 million. Yeah, getting to 292 is going to take a little bit, right? So eventually one of the things we can do is go and optimize this. We will get to those sorts of things to look at why is this slow, what's slow about it here, that sort of fun stuff, right? But for now, it was close enough, right? And we didn't get a jackpot. It would take a little while. We could let that run for as long as we wanted to and get bored of it eventually, but that's okay. What is it not like about winning ticket? Shadows the name winning. That's fine. I don't care. Yeah. Does that make sense? If you've never done Python before and you're jumping in new, that's okay if this was a little bit weird. If you took 1501, I think all of this tracks really easily. If you forgot it all over break, that's okay too. We'll pick it back up. That happens too. Just remember the important things, right? So we go commit this to GitHub. 2001, winter, Powerball, commit, and push. All right, so it'll be out there in the course repository. I'll post the recording for you. If you got questions or concerns, let me know. If not, we'll meet at noon on Tuesday for our Unix lab. Yeah?
This DEN.
Yeah. That defines a function. Yep.
How would you put _IN?
So this is the init. This is like your constructor. It's the Python constructor, our initialize function. That's how you create an instance of the object. So when we say I want a Powerball ticket, parentheses, that will call the init function.
So you have to do _.
Yeah. Double underscore init double underscore. Yep. Python has a bunch of these double underscore things that mean a bunch of things. Like our string was a double underscore str. It's just a convention in Python. There's a bunch of under something under functions you can write. Yeah, they're going to look a little funny, but we'll get used to them as we go. Eventually, you can add things like less than and greater than. So we could define a less than of another Powerball ticket. How am I less than? I don't know how to. That doesn't actually make any sense. But when we start talking about other classes, this instance of class could be less than this instance of class. You know, maybe we look at the area of a square, and we'll say, oh, okay, you're less than if your area is smaller. I don't know. Any way we want to define it, whatever makes sense in our code, we can add more of those functions here. But there's a bunch of these built-in ones here.
That return, you have a return, you have to
So this is string join. It will take a list and put it together with this being the separator. It's just a little shortcut, right? I could say, hey, here's my value is quote, and then for number in self numbers, self dot numbers. I could take my value plus equals the string of the number plus a space here, right? And then go through and add them all together. And then at the end, I would want to return my value sliced -1, right? Because I don't want the last space. You have to take off the very last space. So this will add number space. So I'll have 6 numbers in a space. I'll have an extra space at the end that I can whack off. That's just a little shortcut for you for doing it here. No, control comment. There we go. So if you're used to regular loops, it looks like this. It's just a shorthand for doing it here. That's all. There's a lot of shorthand things people like to do in Python.
Value plus equals. Okay, let me still join it. What's value plus equals?
So take the value I'm going to return, and I'm going to add to it. Just concatenate in the string. Just start smushing strings together. So this is actually terribly inefficient because it builds out 6 different strings in memory and throws out the first 5. It's like, because you can't change a string. Strings are immutable. So every time you add to a string, it makes a new string in memory, throws out the old one. So I had a string with a number, and now I threw that out, made a string with 2 numbers. Threw that out, made a string with 3 numbers. Threw that out, made a string with 4 numbers. So this is one of those inefficiencies where string join will just kind of do it all at once in a more efficient manner for you, which is cool. The coffee's kicking in. I'm feeling a little better now.
I'm sure you, like, you haven't used PyCharm before. How do you set it up to get the auto suggestions or like that picture frame that shows up and says,
Oh, you just hover over. It's just built in.
really?
Yeah. So if there's something that it can look
okay,
up.
I'm just not hovering long enough, not
Yeah.
patient.
So, and that's where like some comments are really nice. Like if you hover over get numbers, it doesn't tell us anything, right? Because we never set it up to do anything. Where it's like get numbers, we never told it anything. You can add a comment here to make it a document comment, doc comment, whatever it's called, to make it give you something. So when you're writing a library for someone else to use, that's fantastic. God bless you for using those comments.
Yeah.
All of our other stuff is just, it's a waste of time to add comments, right? We're just doing exercises in class. And I trust that if you can actually do class exercises, you can learn the comment doc format. It's like a triple quote and some stuff. Like, it's just a waste of our time. All right, awesome. I have been in alternate loop. Alternate slow loop. I'm sure you don't mind my spelling mistakes, right? It's cool, it spell checks now, even in GitHub. That's like super handy. I love when tools spell check for you, because I don't know how any of that works.